Welcome. This session is on ensuring a KML file is in the proper format to work on a SmartOTU OTDR port. Loading and using KMLs with SmartOTU, the optical alarms have a Latin long of the fault reported and show up on a map. Note a KMZ is a combination of numerous zipped KMLs. In this network map, there is over 1,000 miles of fiber. If the OTU is monitoring one 50-mile span, there's no way, if a KMZ is loaded, for the OTDR to know what portion to monitor. A KML must be created from the KMZ. The SmartOTU KML format is that the start point of the map route must match the start point of the OTU. If this is drawn backwards, then a break at the OTU would appear at the end of the span. A map route may contain many segments. If there are segments, they all must be drawn in the same direction. If the route is from the OTU east, all segments must be drawn in the east direction, and all segments must be completed so there is one complete route or span. If the fiber route is about 10 miles, then the OTDR trace should be about 10 miles. No manholes, handholds, landmarks, buildings, etc. go in the KML. It's a straight fiber route, but the start and end point can be named. If the route is not compatible with these SmartOTU rules, then the KML can be fixed or redrawn. Here's an example of a route that has many segments. If this is too many segments to handle, most GIS folks know how to pull a KML out of a KMZ so it is just one segment or a few segments. Here's some examples. To monitor the point 1, if the map route is from the OTU due west to point 1, that will work. To monitor the point 3, the map route needs to go from the OTU west, south, then southwest, and then northwest. That would work. For route 2, the item in black, there appears to be two fiber ends, so this would not work for SmartOTU. To monitor this spoke off of this main route, a loopback fiber needs to be used. So in the red picture going to route 2, a fiber is monitored, then a fiber monitors to that spoke, such as a business, a customer, or a cell tower, and a second fiber is monitored back to the main route, and then the route continues to the end at point 2. So now to the OTDR, there is one physical route and there is one map route. For the fourth route, coming from the OTU, it's due north and then due east. However, there's multiple segments and the segments are not connected. So the OTDR and SmartOTU has no way of knowing what the route actually is. This one can be monitored if it's corrected. SmartOTU knows that the fiber length is longer than the cable length, so it compresses the fiber length to match the cable length. An example is the OTDR trace is 1,100 meters, but the ground length is 1,000 meters. The OTDR will show a break at 500 meters or halfway down the span. Well, halfway down, the ground route is 500 meters, so the alarm will be at 500 meters and not 550. This method autocorrects for slacks, up and down poles, sag, and helix. No documentation is required, is normally very accurate and useful for identifying faults. If a KML is not compatible, two common methods to fix it are to load a KMZ and then draw the route in Google Earth. The second way is to pull a KML out of a KMZ or have a KML and edit in free GPX editor. VIAVI has a quick card for each method. GIS users may also have other techniques as well. Thank you.